Today, we're going to talk about writing numbers in scientific notation. Scientific notation is a format that very large numbers, such as the distance from the Earth to the Sun, and very small numbers, such as the size of an atom, are written in. This allows us to easily read those very large or very small numbers, as well as perform operations with them. When we write numbers in scientific notation, there's a very specific format that they must follow. First, it's written as a product, which means the multiplication of a number and a power of 10. So if you look at the numbers at the bottom, you can see we have a number being multiplied by the power of 10. The number must be greater than or equal to 1 and less than 10. That means that first digit cannot be a 0 or a 10. The last rule that the format must follow is that the power of 10 must be an integer exponent. The power cannot be a decimal or a fraction. When the exponent is positive, that means we're dealing with a number greater than 1. When the exponent is negative, that means we're dealing with a number less than 1. So let's break this down and write a number from scientific notation into standard form. Standard form is just the number form. So what is the actual number being represented? So here we have the number 4.205 times 10 to the second power. This has a positive exponent, so we're dealing with a larger number. What does 10 to the second power really mean? Well, 10 to the second power is 10 times 10, which is 100. So what we really have is 4.205 times 100. When you multiply those, you would get 420 and 5/10. 4.205 times 10 to the second power is really 420.5. What do you notice about the movement of the decimal? If you thought by taking 4.205 times 10 to the second power was really just shifting the decimal 2 places to the right, you're correct. We could go through the multiplication process for every problem, but it's much easier to simply move the decimal. Now here are some things to think about when writing numbers in scientific notation. If you have a positive exponent, that means you're dealing with a large number, so we're going to shift the decimal that many places to the right. When we have a negative exponent, that's when we're dealing with a smaller number, or a number less than 1. So we're going to shift that decimal that many places to the left. Let's look at these two examples. The first example is 2.56 times 10 to the fourth power. Because we have a positive exponent, we're going to move that decimal place that many times to the right. So we're going to go 1, 2, 3, 4. Now we have a new decimal location. And notice we have those empty spots. We can plug zeros into those spots. So 2.56 times 10 to the fourth power is really 25,600. Now let's go through an example with a negative exponent. When we have a negative exponent, we're going to shift that decimal that many places to the left. So we have 1, 2, 3, 4, 5, and a new decimal location. We can fill in those empty spots with zeros, and then we always want that leading 0. Now we have our number written in standard form. Let's go from writing numbers in standard form, which is just number form, into scientific notation. When you do this, remember the format the scientific notation has to follow. Let's start with writing numbers greater than 1 into scientific notation first, and then we'll move to numbers that are less than 1. Let's first try writing the number 130,000 into scientific notation. The first step is to put the decimal clear at the very end. After we do that, we have to decide where we want that decimal to end. The format of scientific notation was that the leading number had to be greater than or equal to 1 and less than 10. So our decimal is going to go in between the 1 and the 3. The next step is to determine how many times we have to move that decimal place. We're going to move it 1, 2, 3, 4, 5 times. So in scientific notation, we have 1.3 times 10 to the fifth power. Now let's write numbers that are less than 1 into scientific notation, such as this one. We want the format to be a number that is greater than or equal to 1 and less than 10, and then the decimal. So we want our decimal to end up in between 4 and 5. We're going to move our decimal place 1, 2, 3, 4 places to the right to get there. So we have 4.5 times 10 to the fourth power, but since it was a small number, we have a negative exponent.